Two other forces include friction and tension. These are both things that we'll encounter at various times. There are two types of friction. There are static and kinetic friction. I like to think of kinetic as a sliding friction. I think your book actually describes it in that way, as sliding friction, two surfaces sliding with respect to one another. And then static, of course, is not moving. So two surfaces that are not moving with respect to one another. We can calculate the frictional force by taking the product of a coefficient, this is the Greek letter mu, times our normal force. The frictional force is equal to the coefficient times the normal force. So the frictional force that you experience is dependent upon the normal force. So then an object that has more weight will have a bigger normal force if it's sitting on a horizontal surface, and so it's going to experience more friction. Also, the coefficient of friction describes the two surfaces. So a coefficient of friction is dependent upon the surface and the material. For example, metal on ice has a really low coefficient of friction. Whereas rubber on wood has a very high coefficient of friction. So this is a low mu, and this is a high mu. So the frictional force is dependent upon both of those things. We have two different types of two different coefficients of friction. We have mu k for kinetic friction and mu s, and it turns out that these are going to be different from one another. In fact, mu k is almost always less than mu s. Kinetic friction, or sliding friction, is always smaller than static friction. And you experience this if you ever push a heavy box across the floor. If you have a heavy box on the floor and it takes some force to push across, the opposing force is going to be the frictional force. After you get it moving, this is our kinetic frictional force. While it's stationary, it's the static frictional force. You might understand this better. Let's say that I have an inclined plane and I have some object that's not moving. It has a velocity equal to 0. I have some component of the weight. I'm going to call it Fwx. It's the x component of the weight. And then up the inclined plane, I have the static friction. The static friction is the force that actually holds the object on the inclined plane. Now, Fs is almost always bigger than Fk. So as you're trying to move this object across the floor, a big heavy box for example, you push on it and initially it's hard to push. But after you get it moving, it's much easier. That's because Fk, the kinetic friction that opposes your motion, is less than Fs, the static friction that opposes the motion. The next thing is tension. Tension is a simple thing as far as we're concerned. If I have a force that's acting here and I want to apply it at a point over here, I can use a rope or cable or something else to connect those 2 points, and then whatever force is experienced here is also experienced here. So a tension is a really nice way to transfer a force from one point to another. And we see that in our body with our muscles and our ligaments, that our muscle will contract at one point in the body, but then that force is applied at another point. For example, your shoulder muscles or your biceps, that they contract at one point in your body, but then they're attached at a different point, at the insertion point, and that's where the force is applied. So we'll see tension come up in the later A and P section of this chapter.